Weather usually follows a familiar script: sunny summers, chilly winters. But sometimes nature throws us a curveball. Every so often the atmosphere delivers a surprise that rewrites the record books and reminds us how unpredictable our planet can be. The winter of 2026 was one of those moments, a powerful lesson in how interconnected our weather systems truly are. What began as a subtle shift above the North Pole grew into a massive event, sending shockwaves across the northern hemisphere. This wasn't just a cold snap, it was a large-scale disruption that reshaped weather patterns for weeks. The culprit? The Greenland block, a phenomenon meteorologists had studied, but never on this scale. In 2026, it became a giant, freezing one continent, while sending another on a wild weather ride. This story is about more than cold air and snow. It's about atmospheric physics, forecasting power, and the influence of a changing climate. Understanding what happened helps us prepare for the future. Let's explore how the Greenland block formed, the chaos it caused, and what it teaches us about our planet. So, what is a Greenland block? Imagine a giant, invisible wall of high-pressure air parked over Greenland. Normally, high-pressure systems drift along, but sometimes one gets stuck, becoming a major obstacle for weather systems crossing the Atlantic. This wall blocks the usual west-to-east flow, forcing the jet stream to snake north and south in dramatic waves. In 2026, the Greenland block was a colossal, stubborn dam, stretching for thousands of miles and refusing to budge. Its size and persistence meant it dictated weather for continents on both sides of the Atlantic. The result? An atmospheric traffic jam, with cold and warm air piling up in unusual places. Unlike typical weather systems that move on in days, a blocking pattern can lock weather in place for weeks. During the winter of 2026, this block's refusal to move was the key reason for the extreme lasting conditions. For millions, it meant relentless cold, persistent storms, or unseasonable warmth, depending on which side of the block you were on. The Greenland block became the main character in the winter's weather drama. The 20,000 mine senu monuken, we stodor tumain. Greenland block's story began high above the ground, in the stratosphere. In January, scientists observed a sudden stratospheric warming, an explosive temperature spike above the North Pole. This event disrupted the polar vortex, a swirling mass of cold air usually trapped over the Arctic. The SSW acted like a punch, weakening the vortex and letting frigid air spill southward. The January 2026 SSW was especially strong, sending atmospheric waves crashing into the stratosphere and destabilizing the polar circulation. As the vortex wobbled, lobes of Arctic air plunged south over North America and Eurasia. This cold air fed and strengthened the high-pressure system over Greenland, helping it grow into the monstrous block. Meteorologists saw the SSW as an early warning, a sign that big changes were coming. The SSW was the first domino, setting the stage for the extreme winter that followed. What happened high above the pole soon reshaped weather for millions below. Once the Greenland block settled in, Europe was hit hard and fast. The jet stream dove south, opening a direct path for Arctic air to blanket the continent in a relentless freeze. This wasn't a typical cold spell, it was the big freeze of 2026, with temperatures plunging far below average from the UK to Poland. Major cities like Berlin and Paris endured record-breaking cold and heavy snow, grinding daily life to a halt. In the Netherlands, canals froze solid for the first time in years, reviving cherished traditions. Even Rome saw a rare snowfall, transforming ancient landmarks but causing chaos in a city unprepared for winter. The deep freeze strained energy grids, disrupted transport, and threatened crops across Europe. The Big Freeze was a stark reminder of how vulnerable Europe is to large-scale atmospheric shifts. While Europe froze, the US rode a weather roller coaster. The Greenland block buckled the jet stream, creating wild swings between spring-like warmth and Arctic blasts. In the Midwest, temperatures could soar one day and plummet by 40 degrees overnight. On the West Coast, the block funneled powerful storms into California, ending drought but triggering floods and mudslides. The block also allowed Siberian air to plunge into the central and eastern US, bringing some of the coldest temperatures and dangerous ice storms. Power outages and travel chaos followed as freezing rain coated trees and power lines. The winter of 2026 showed just how extreme and varied US weather can be under a single blocking pattern. It was a lesson in atmospheric unpredictability. To understand the chaos, we need to talk about the jet stream, a fast-flowing river of air high above us. When it flows straight and strong, weather systems move predictably, but the Greenland block forced the jet stream into huge looping waves called a meridional flow. Over the Atlantic, it bent north to get around the block, then plunged south over Europe, trapping Arctic air. In North America, the jet stream bulged north, pulling up warmth, then dipped sharply, unleashing cold. These slow-moving waves locked weather patterns in place for weeks. Europe was stuck in a deep freeze. The US swung between extremes. The Greenland block didn't create the cold or warmth. It rearranged the atmosphere, steering air masses into unusual places. The result: persistent, memorable weather on both sides of the Atlantic. Extreme events like the 2026 Greenland block can't be separated from climate change. The Arctic is warming 2 to 3 times faster than the rest of the planet. A phenomenon called Arctic amplification. Melting sea ice exposes dark ocean, which absorbs more heat, accelerating warming. This rapid Arctic warming weakens the jet stream, making it more likely to form big, slow-moving waves and blocking patterns. A weaker jet stream means more opportunities for weather to get stuck, leading to longer cold snaps or heat waves. The 2026 event suggests climate change may be making blocks like the Greenland block more common or intense. The chilling message: changes at the top of the world can trigger weather extremes thousands of miles away. The Greenland block was a real-world example of our planet's interconnectedness. It's a warning that global warming can bring paradoxical outcomes, like brutal cold in a warming world. One bright spot in 2026 was the success of modern weather forecasting. Meteorologists spotted the sudden stratospheric warming weeks in advance, using satellites and computer models. This gave them time to warn governments and the public about the coming cold wave in Europe and volatile weather in the US. Early warnings allowed cities to prepare snowplows, energy companies to brace for demand, and emergency agencies to open shelters. These forecasts turned a potential disaster into a more manageable challenge. The event proved the value of investing in weather and climate science. While we can't stop a Greenland block, seeing it coming lets us prepare and save lives. Accurate, timely information builds resilience against extreme weather. The Greenland block of 2026 was more than a wild winter. It was a global lesson. It showed how a single atmospheric feature can rewrite weather for millions, freezing Europe and sending the US on a temperature roller coaster. The event made clear the link between a warming Arctic, a weaker jet stream, and more extreme, persistent weather. It also proved the power of modern forecasting to save lives and reduce damage. The paradox: global warming can lead to severe regional cold. The lesson: understanding our atmosphere is key to preparing for its surprises. Events like this highlight the need to both cut emissions and adapt to new climate realities. By learning from this weather monster, we can build more resilient communities. The atmosphere will always surprise us, but knowledge gives us the power to respond.